Luckily, at the end of the last servicing mission, we were actually left with a telescope in great condition with a new suite of instruments. Hubble is still going very, very strong. It's still producing science that people are going, wow, we didn't know that. It's just amazing.
The Hubble Space Telescope. Technology has shaped our world in many ways, and the Hubble Space Telescope is a perfect example. The Hubble Space Telescope, launched in 1990, has completely changed how we perceive the cosmos. It has made it possible for us to study Earth and its surroundings in unprecedented detail and improved our understanding of faraway galaxies and star formations. Watch this video to learn more about how technology has influenced our world. The Space Shuttle Discovery carried out the launch and deployment of the NASA Hubble Space Telescope in 1990, which was a technological marvel for its time. Over its lifespan, it has recorded more than 1.5 million observations. Even more unexpectedly, NASA has discovered that the 1990 launch of the Hubble Space Telescope was only intended to endure about 15 years. 5 successful astronaut servicing trips have been used to modify and advance the Hubble Space Telescope's equipment, and as a result, the telescope remains scientifically productive to this day. In this video, we'll look at the Hubble Space Telescope. Before we proceed, please give this video a thumbs up and subscribe to this channel for more content. In order to subscribe to new video alerts, click the bell symbol. Have you already put it into action? Let us continue. The Hubble Space Telescope is what exactly? A huge telescope in space is called the Hubble Space Telescope. On April 24, 1990, the Space Shuttle Discovery was put into orbit. Approximately 535 kilometers, 332 miles above Earth, Hubble orbits. It weighs as much as 2 mature elephants and is the length of a large school bus. Hubble moves at a speed of around 5 miles per second, equivalent to moving in 10 minutes from the US East Coast to the West Coast. Hubble runs on solar energy. Planets, stars, and galaxies are just a few of the sky objects that Hubble captures in clear images. Hubble has made more than 1 million observations. These comprise in-depth images of galaxies located billions of light years distant, comet fragments colliding with Jupiter's atmosphere, and the formation and demise of stars. These images have taught scientists a lot about the universe. Many of them have lovely visuals. Edwin P. Hubble, an American astronomer, is the subject of the name Hubble. In the early 1900s, he made significant discoveries. He demonstrated that the Milky Way galaxy, which houses our solar system, is but one among many galaxies. His research aided in demonstrating the universe's expansion. The Big Bang Theory contends that the universe started with a powerful explosion of energy and has been expanding since it was born as a result of this. Where the Hubble Space Telescope is. At around 332 miles, the Hubble Space Telescope orbits just above Earth's atmosphere, 535 kilometers. Every 95 minutes, Hubble completes an orbit at 17,000 miles per hour, 27,000 kilometers per hour. Hubble can capture crisp photographs not by traveling or flying closer to celestial bodies, but by being above Earth's atmosphere. Hubble is elevated above Earth's hazy atmosphere despite being close by, giving a clear perspective of the cosmos. Light is distorted and blurred, and some electromagnetic spectrum wavelengths are absorbed by Earth's atmosphere. The atmosphere not only hinders the ability of ground-based telescopes to obtain sharp views of cosmic objects, but also helps shield us from hazardous radiation. How the telescope works. The mirror-based optical system of the Hubble Space Telescope gathers and concentrates light from the cosmos for scientific and navigational devices to study. Hubble's optical equipment, known as the Optical Telescope Assembly, OTA, collects infrared, visible, and ultraviolet light to provide a distinctive picture of the cosmos. A skeleton made of graphite epoxy supports the OTA. Because it is lightweight, stiff, and robust, graphite epoxy, also used in bicycles, tennis rackets, and golf clubs, was selected for the OTA's frame. The graphite epoxy is resistant to expansion and contraction brought by the temperature changes that Hubble encounters as it orbits the Earth, even if the frame somewhat compresses as water vapor embedded in it escapes into space. Hubble's mirrors are maintained at a constant temperature of roughly 70 degrees Fahrenheit to prevent warping caused by temperature variations, 21 degrees Celsius. How long is Hubble expected to remain operational? Hubble was designed to last roughly 15 years when it was launched in 1990. The Hubble Space Telescope has undergone 5 successful astronaut servicing missions, and as a result, the telescope's equipment has been updated and enhanced. The telescope is still useful for science today. The telescope is expected to be operational through the end of the 2020s and possibly beyond. The only telescope made with astronaut maintenance in mind is Hubble. All 5 of the telescope's primary instruments have been replaced, updated, or repaired during 5 space shuttle trips. Following the Columbia tragedy, 2003, the 5th mission was temporarily shelved due to safety concerns. However, after NASA Administrator Michael D. Griffin approved, the HST was finished in 2009. It has been in service for 30 years since April 2020 and is expected to continue until 2030 to 2040. Who decides what Hubble looks at? Hubble's science activities are managed by the Space Telescope Science Institute, STSCI, based in Baltimore, Maryland. The Hubble proposal selection process is managed by STSCI along with scheduling the ensuing observations data processing, etc. Hubble time is a valuable but highly competitive resource. The Time Allocation Committee, made up of about 150 experts from around the world, evaluates and ranks proposals. The applications are assessed for their scientific value, and the committee then recommends a winner who is given the go-ahead from the STSCI director. Additionally, 10% of Hubble's observation time is reserved for the director's discretionary uses. The director's discretionary time has funded observations like the Hubble Deep Fields and the Hubble Frontier Fields. Capturing light. Hubble uses 2 mirrors arranged in a Cassegrain telescope configuration to gather and concentrate light. The concave, bowl-shaped primary mirror is where light strikes after passing through the telescope's length. The primary mirror is a reflector sending light back toward the telescope's front. It then strikes the convex or dome-shaped secondary mirror there. A dinner plate-sized beam of light is focused by the secondary mirror into a path back toward the primary mirror, where it passes through a hole. After that, the light is focused on scientific and navigational instruments for analysis. The mirrors on Hubble have a deeper curve than a typical parabolic Cassegrain mirror because they are hyperbolically curved. A Ritchie-Chrétien design is a version that offers clearer images over a larger field of view. The secondary mirror is only 12 inches, 30.5 centimeters broad, whereas the major mirror has a diameter of 7.8 feet, 2.4 meters. Since Hubble can gather 40,000 times more light than the human eye due to its large primary mirror, it's possible to view aircraft landing glides over San Francisco from Washington, D.C. The main mirror is substantial, yet it was made as light as possible. Hubble's primary mirror weighs 1,800 pounds rather than the 8,000 pounds, 3,636 kilograms it would otherwise have with the solid core, 818 kilograms. Both mirrors have thin magnesium fluoride and aluminum coatings. The reflectivity of the mirror is provided by a thin layer of aluminum that is only 3 to 1 millionth of an inch thick. Aluminum is covered with a layer of magnesium fluoride to prevent oxidation and improve UV light reflectance. The coatings in mirrors are incredibly smooth. The Hubble telescope's primary mirror is so smooth that the biggest peaks on the surface would only be 6 inches, 15 centimeters tall, if the mirror were stretched to Earth's diameter. What has the Hubble mission cost? Since the Hubble mission's official launch in 1977, it has cost roughly $16 billion adjusted for inflation to 2021 USD. The price of running the space shuttle for missions to deploy and maintain Hubble is not included. Who paid for it? Space telescopes were first envisioned in 1923, and the Hubble telescope was funded and constructed in the 1970s with assistance from the European Space Agency. The project was plagued with funding issues and technical delays, and the Challenger catastrophe in 1986 prevented it from taking off in 1983 as planned. When Hubble was ultimately launched in 1990, its main mirror exhibited spherical aberration due to improper main mirror grinding, which limited the telescope's capabilities. A servicing mission in 1993 successfully adjusted the optics to their expected quality. What are Hubble's most significant findings? Scientists have used Hubble images to determine the age and size of the cosmos. The universe is thought to be about 14 billion years old. Hubble has aided in the understanding of galaxies and planet formation. The furthest galaxies ever observed are depicted in an image dubbed Hubble Ultra Deep Field. Black holes, which absorb everything around them, including light, have been discovered by Hubble. The discovery of dark energy, a puzzling component that drives the cosmos to expand more quickly over time, was made possible in large part by the telescope. Additionally, it has provided information on gamma ray bursts, which are strong energy explosions caused by the demise of huge stars. Hubble has also investigated the atmospheres of planets that revolve around stars comparable to the Sun. Hubble's photos' level of detail has been essential to their continued success. Astronomers have been able to use it to observe the changing weather and aurora on distant planets, calculate the gravitational light bending caused by dark matter, look into stellar structures, and catch a peek at planets orbiting other stars. Bob Williams, the director of Hubble, used it to focus on one area of space for 10 days straight in the latter part of 1995. Thousands of galaxies were visible in the Hubble Deep Field photos, some of which are 12 billion light-years away from the Earth. Here are some of its major contributions to science. Contributed to determining the universe's age, which is currently estimated to be 13.8 billion years old, roughly 3 times the age of Earth. Nix and Hydra, 2 moons of Pluto, were found. Contributed to the measurement of the rate of cosmic expansion. Found that the black hole at the center of almost every large galaxy serves as its anchor. A 3D map of dark matter was made. Undoubtedly, the Hubble Space Telescope is one of the most amazing pieces of technology ever made. We can view objects in space that would have been otherwise impossible to see thanks to this telescope, which was constructed in the late 1970s and early 1980s. This telescope not only gives us stunning visuals, but it has also made it possible for researchers to study the universe in previously unimaginable ways. Our understanding of the cosmos has changed dramatically due to the Hubble Space Telescope. Hubble has significantly impacted our understanding of space and time, from its groundbreaking studies of the Large and Small Magellanic Clouds to its famous photo of the surfaces of 2 neutron stars. Today's video has come to an end. Give the channel a thumbs up and subscribe if you enjoyed the video. Remember to click the bell symbol to receive notifications when new videos are posted. I will see you in the next video. Until then, bye.